Welcome back. In this fourth video of our data science project series, we'll build a model to predict the NBA games winner. Besides modeling, we'll evaluate the model and tune the hyperparameters to improve the performance. Hi everyone, I'm Justin. Welcome to Justin to Data, where data science materials are shared and made simpler for you. Alright, let's start from the typical first step of modeling, the train-test split. We'll randomly split the dataset into a training and a test subset so that we can train the model using the training set and evaluate the model using the test set. We'll use the handy function in scikit-learn. Let's do from sklearn model selection import train-test split. Then we'll say dftrain, dftest, the training and test sets equal train-test-split function with argument as the games model. This is a data frame we've cleaned up in the previous video. Then we can also add stratify as games models WL home column in case we have an imbalanced dataset. Then we'll set the test size as 0.2. So 20% of the data will be the test set, while the rest of the 80% will be the training set. It's also optional to add the random state as an integer, say 7. This guarantees us the same results each time we run the split on the same dataset. Done. Now we can check the shape of the train and test datasets. So there are 908 number of rows in the training set and 228 rows in the test set, which is about 20%. Next, we need to identify the target and separate it out from the other features. Let's call the variable target as WL home, since within our data frame, the WL of home team is a target we're trying to predict. Then we can say xtrain as dftrain, drop columns as target, while ytrain as dftrain, target. So we're saying all the other columns, other than WL home, is the xtrain, which are the features, which is actually only one column of the average plus-minus difference. While ytrain, the target, is the WL home column. Similarly, we can copy the same code and change all the train to test. So now we have xtrain, ytrain, xtest, and ytest. Now we're ready to train the model. In real-life situations, data scientists often try a couple different models that are suitable for the problems. For our project, it is a labeled classification problem. The popular models are logistic regression, random forest, and so on. We'll focus on xgboost to show the general steps of modeling. xgboost is a popular gradient boosting library. It is easy to use, fast to run, and often gives good performance. This has been proven since many Kaggle competition winners used xgboost. So let's try it out. If you haven't installed xgboost, you can install it with the pip install xgboost statement. Then we'll import xgboost as xgb. So we want the xgboost model to work within the scikit-learn package, because later we want to use the scikit-learn functions on such a model. What's the function we should use? Again, we can Google it. Say xgboost scikit-learn classification. There it is. From this article, it says xgboost provides a wrapper class to allow models to be treated like classifiers in the scikit-learn framework. This means we can use a full scikit-learn library with xgboost models. And the model for classification is called Xgb Classifier. So let's try it out. So Xgb, XGBoost, Xgb Classifier will leave most of its parameters as the default settings. Just set random state as an integer, say 7 again. This random number seed guarantees we have the same outputs from time to time. And let's call it CLF for classifier. Now we have the Xgb classifier set up. We can use it to fit the data. So CLF fit xtrain, ytrain, and let's run it. We got some warning messages. The use of label encoder in Xgb Classifier is deprecated and will be removed. To remove this warning, pass option use label encoder equals false. Encode your labels. So it's optional, but we can add it in the classifier. Use label encoder equals false. Let's run it again. That warning message is gone, but there's still another warning. Apparently, the default evaluation metric used with the objective binary logistic was changed from error to log loss. So we should explicitly set eval metric if like to restore the old behavior. It's optional too, so I'll just leave this warning message as is. At this point, we've got our model fitted based on our training dataset. It's time to evaluate the result. There are different evaluation metrics available on scikit-learn. Let's Google it. As you can see, for classification problems, there are many different metrics. Let's try the most basic one, accuracy. We'll click the metric and scroll down to see the example. So we can copy from scikit-learn.metrics import accuracy score. We need to use this function on the actual label and predicted label of the test set. So let's calculate ypred as CLF, the xgboost classifier, predict of xtest. So we store the predicted results in ypred. We can then use the metric accuracy score to compare ytest, the actual label, and ypred. So around 60% of the predicted results were accurate. How can we improve the performance? We can try to tune the hyperparameters of the XGBoost model. If you're not familiar with hyperparameters, it is the parameters whose values are set before the learning process begins. For example, for the XGBoost model, we can press Shift-Tab to read its documentation. It has hyperparameters such as n estimators, which is the number of boosting rounds, max depth, the maximum tree depth for the base learners, learning rate, and so on. When building this model, we just left these hyperparameters as default, but tuning their values could potentially improve the model performance. So let's try it out. There are different approaches to tune the hyperparameters. We'll stick to a basic approach called random search. We can search for scikit-learn random search. This one, the randomized search CV, is the one we'll be using. It performs randomized search on hyperparameters. In this approach, not all parameter values are tried out, but rather a fixed number of parameter settings is sampled from the specified distributions. So it won't be an exhaustive search. That's why it's called the random search. It's random so that it can be executed in a shorter time while still giving good results. You can read more about it in this documentation, or even click the user guide for more information. I'll just quickly set it up. So from scikit-learn model selection, import randomized search CV. Then we'll say random hype equals randomized search CV with argument as a few parameters. Estimator equals CLF, since CLF is the model we're trying to tune. Param distribution equals, here we can give a dictionary with parameter names as keys and distributions of lists of parameters to try. It's going to be pretty long, so I'll create a new variable, call it hype params, to leave here. We can define it in a cell above. Say hype params equals a dictionary. We'll only tune a couple of hyperparameters, say learning rate, max depth, subsample, and n estimators. There's usually no clear set rules when doing hyperparameter tuning. A lot of things are based on experience or trials and errors. For the learning rate, we often use the log uniform distribution. Let's say log uniform of a small number, 0.0001 to 1, This log uniform function we need to import as well. So we can add above, from scikit-learn utils fixes, import log uniform. For the max depth, we'll give it a list of integers, say 2, 3, 4, 5, 6, 7, 8, and 9. For subsample, we'll do a random list of numbers, say 0.7, 0.8, 0.9, until 1.0. For the n estimators, we'll do 50, 100, 150, and 200. Good. Now we have a dictionary set up for the param distributions. We'll also add more arguments as n_iter equals 20, so that there will be 20 parameter settings sampled from the param distribution we provided. We have to pick an appropriate value for this n_iter since it trades off runtime and the quality of tuning. Then we'll set CV, the cross-validation, as say a value of 7 folds. I just picked this value randomly. Usually it's a number between 5 and 10. The parameters of this model are optimized by cross-validated search over the parameter settings. We'll also set scoring as accuracy. This is a strategy to evaluate the performance of the model on the test set. We'll also add a random state as integer, say 7 again. Then we can run this and say random hype fit to xtrain and ytrain. Let's run it. It's pretty fast since our model is small. We're getting all these warning messages since we didn't set the evaluation metric, but it's okay. Let's wait for it to finish. It's all done now. Let's hide the output. We can look at the results. To see the final results chosen, we can do random hype best params underscore. You can see the values of the parameters that were chosen. How do we use this best parameters to predict? We can do random hype best estimator underscore. Let's store it as model hype for hyperparameter. Then we can say ypred hype equals this model hype predict using xtest. To evaluate this model again using the accuracy score, we can do accuracy score ytest. Then this ypred hype. It is 61.4%, so this is a slight improvement from before, which was 60%. So now it's 61% accuracy. So this is good that we got a slight improvement, but sometimes we could get a much larger improvement depending on the number of iterations of the random search, the dataset, and also the model. There are also other methods of hyperparameter tuning. We published an article before. It shows an example of a more advanced tuning approach. You can check it out by following the link in the description. There's of course other things that can be done to improve the model. For example, we've only used the plus-minus points to create the feature. There are other statistics that might be included as features as well. Or you can try to use other models for prediction as well. In the next video, we'll deploy this model using FastAPI. It is important since the model needs to be put into production for use in applications. Did you learn something new in this video? If so, make sure to subscribe to our YouTube channel. Just click the subscribe button below this video right now. If you're interested in more data science tutorials and courses, please head over to our website justintodata.com. Thank you and see you in the next video.